Hello and welcome to our presentation on our grocery store database. Our database was designed by Anna Gibson, Daisy Chan, Ian Raynal, myself, Kari Simonson, and Trevor Dorn. In today's presentation, we'll be going over our database design document, our ERD or Entity Relationship Diagram. Then we'll look at the SQL DDL statements that built our database. And finally, we'll check out some SQL views and visual reports that reflect what our database can do and how it can be useful to the business. To start, I'd like to go over our database design document. This document maps the business purpose to the target database management system with consideration of any business rules stipulated by our grocery store. So, what is the purpose of our database? The purpose of this database is to maintain reward card customer data for a franchise grocery store in the Pacific Northwest. This will be used by regional management to shape buying decisions and incentivize sales. Next in our design document are the business problems, which our database will help to address. We would like to allow grocery store franchise administration to make informed business decisions based on reports from this database. This will help to provide insight on customer demographics, customer shopping behavior, and inform reward card marketing initiatives. This will also allow for sales staff to analyze customer reward usage and allow sales staff to refine reward card promotions. These are a few problems identified in our design document. Next are the business rules. These are the rules of the grocery store that will apply certain constraints during the database design process. On the right are a couple examples of the business rules. For example, each customer will only have one reward card number, and each customer will only have one customer address. In order to create a uniform and stable database design, we have certain database design requirements that we will follow. We will use crow's feet notation to create our ERD. We'll specify primary key and foreign key fields using PK and FK. And we'll use lines between fields and dotted lines to illustrate the types of relationships between entities. There are a number of other design requirements that are listed in our complete document. The final key component of our database design document are the design decisions. These decisions describe the reasoning behind the inclusion of each entity and the relationships between entities. For example, our entity customer address is useful in keeping up-to-date address information on each customer. This can help with sending out promotional mail and also which stores might be the primary store at which a customer shops.
Our ERD design gives us a better look at the different relationships between the stored data in our database. I will start with our parent entity customer. This table stores basic information such as first and last name along with the unique customer ID. All child entities connected to customer all have a one and only one relationship, and most of them also have a non-identifying relationship to customer because they are not dependent on the parent entity and can exist without it. And this is depicted through the dotted lines. Customer address stores information on street names, cities, state, and zip code, while reward account information has attributes of date issued and closed of the reward account along with their total number of transactions and phone number. Monthly customer visits stores data on the date visited by the customer, while monthly visits stores data on which store was visited by the customer along with the month and the customer count. Third party vendor customer bridges the customer and the third party vendor together through the PKFK third party vendor ID and customer ID. Third party vendors are companies and businesses that deliver the groceries to the customer. The transaction entity stores data on the transaction type and payment related to the PK transaction ID and FK customer ID. Now shifting over to the parent entity store, which has attributes detailing the PK store ID along with the street name, city, state, and zip code connected to it. There is also monthly visits and their party vendor, which we went over previously. The two new tables are promotion and store type. Promotion entity connects store, product, and reward account information through its associated PK and FK. This entity also contains information on promotion type, such as the type of discounts given at the stores. Store product bridges store and the product table together, but also provides a product count, which is the inventory of the items at each store. Lastly, the product entity gives data on price, brand, description, weight, and name of the product, which all are associated through the PK product ID. This table tracks products purchased, which allows us to provide data on customer reward purchases. Connected to this table, we have store product, promotion, and transaction product. Product has a one-to-many relationship with store product because the minimum requirement is to at least have one item in store and the maximum is to have as many items in store. Product also has a zero-to-many relationship to promotion as either no products will have a promotion or there can be multiple promotions for a product. Lastly, transaction product bridges together product and transaction by the PKFK transaction ID and product ID, which allows users to track how each transaction is related to a product.
In this section, we'll go over the SQL DDL statements utilized in creating our database. As shown in the ERD, our database consisted of 15 tables. Our three main tables to construct were customer, store, and product. These three tables were central to our overall database, requiring no foreign keys, just simple implementation of data variables. The rest of our tables consisted of at least one foreign key. When constructing the script for this database, knowing which foreign keys related to which tables helped sequence table creation to eliminate errors. All of our tables followed the default .dbo schema. Household demographics utilized a computed column to generate the total num household element. This was accomplished by utilizing the as function to combine the num adults and num children elements together to produce one unique value. In the product table, the price and weight elements use the auto increment statement. The price states that it is a numerical value, allowing up to 10 spaces with 2 spaces behind the decimal allowed. This is accomplished through the decimal function. Similarly, weight is also allowed the same functionality. Store product uses a check constraint to limit retrievable objects to items that have less than 1,000 quantity inside the database. This is to limit items that register as having an abnormally large quantity of stock. Store product also uses a primary key clustered statement, combining product ID and store ID elements to create a PK store product element, allowing each product quantity to be related to each store uniquely. Similarly, third-party vendor customer, monthly customer visits, and monthly visits also use the same primary key clustered type statements to generate their unique primary keys as well. Up next, we'll discuss the views we tested for our reporting purposes.
Once our database was implemented, we created two views that can help database users with day-to-day projects. The first view returns basic information about users living in Washington state. The second view gives employees in charge of store inventory the information they need to track product supply in each grocery store location. View 1 is designed to return useful customer data. It selects attributes from multiple tables to return customer ID and customer first and last names for those shoppers who live in Washington. This is accomplished by joining these columns from the customer and customer address tables and returning data from only those rows with Washington as the state value. This is helpful for database users that need info about shopper location. As our grocery chain has many stores throughout the country, sales promotions will often be targeted at users living in a specific state, in this case, Washington. View 2 shares inventory data of all products from all stores. This is achieved by joining three tables, product, store, and store product, one of our associative entities where the product count data is stored. Data is selected, including store ID, product name, and product count. This view is especially useful for those managing supply in each grocery store. By selecting all data from the second view, we are given a table showing the amount of each product that each store has. In this instance, we have ordered the data by store so that we can see what products are held by each location. For example, the store that is identified by store ID 2 has 66 kettle corns and 100 lemonades in stock.
For the final task in our assignment, we decided to use the integrated data mining tool of Google Data Studio. This tool allowed us to take data pulled from our database and present interesting findings. For this first report, we used the inventory by store view referenced in earlier slides to pull data out of our database. We wanted to see how much inventory is available for each product, regardless of the store location. Both of these charts display inventory of products throughout all stores in our database. We also offered up two different chart types, the column chart and the donut chart. For our second set of reports, we created a new query that pulled the customer ID and customer state data. We wanted to see how many customers were associated with each state. You'll see most of our customers reside in Washington state. Two different chart types, the bar chart and pie chart, show interesting ways to highlight our data. Thank you for watching our presentation. We appreciated learning practical skills to take with us into our librarian careers.